1. Which of the following expressions are polynomials? 5x square minus 7x plus 4. There are two conditions that a polynomial should satisfy. The first one is the coefficient of x should be real numbers, and second one is the powers of x should be non-negative integer. In the given problem, the coefficient of x are 5 and minus 7 and plus 4, which are real numbers. Power of x is 2 and 0, which are positive integers. So students, both the conditions are satisfied. Hence, it is a polynomial. Let us see whether 5a square plus square root of a plus 4 is a polynomial. Step 1. Well, we have to check the coefficients of a and the powers of a. The coefficient of 5a square is 5. Coefficient of square root of a is 1 and a raised to 0 is plus 4. All are real numbers, so it satisfies the first condition. Step 2. Let us check the powers of a. The power of 5a square is 2. Now, root a is raised to the power half. The power of a raised to 0 is 0. So, 1 upon 2 is not a non-negative integer. It is a fraction, so second condition is not satisfied. So it is not a polynomial. Now, eighth problem of question 1. 3x raised to power of minus 2 plus x raised to power of minus 1 plus 5. Check whether it is a polynomial. Well, it satisfies the first condition of coefficients, which says that they should be real numbers. But it does not satisfy the second condition, which says that the powers should be non-negative integer. Since minus 2 and minus 1 are negative integers, hence it is not a polynomial. Question 2. Y raised to power of 2 upon 3 plus 7y minus 8. On looking the power of y, we can see that it does not satisfy the second condition, since 2 upon 3 is a fraction and not an integer. So, the expression is not a polynomial. Exercise 3.7. Question 3. Degree of a polynomial. We now understand the meaning of a degree of a polynomial. In a polynomial with one variable, highest power of the variable is its degree. Let us take the example 4p minus root of 5. Here the power of 4p is 1 and in root of 5 the power is 0. Hence the degree of the polynomial is 1. Now remember students, the degree of a non-zero constant polynomial is 0. Let us take the example of minus 3 upon 2. In minus 3 upon 2, the power is 0. Minus 3 upon 2 is constant polynomial and can be written minus 3 upon 2 multiplied by p raised to 0. The degree of minus 3 upon 2 is 0. When a polynomial has more than one variable, the sum of the powers of the variables in each term is taken and the highest sum obtained is the degree of the polynomial. Let us find the degree of the polynomial 5x square yz cube plus xy raised to 4z square. The sum of the powers in 5x square yz cube is 2 plus 1 plus 3, which is equal to 6. And in xy raised to 4 z square, it is 1 plus 4 plus 2, which is equal to 7. Hence the highest sum is 7. So the degree is 7. Exercise 3.7. Question 4. Standard form of polynomial. We now understand how to write a polynomial in a standard form. When a polynomial p multiplied by x is written in either ascending or descending powers of x, then such a form is called standard form of the polynomial. 3x minus x raised to 4 plus 5x cube plus 2x square minus 5 in descending standard form. Hence we begin with highest power of x, which is 4. So we write minus x raised to 4 first, followed by next power, which is 3. So we write plus 5x cube and then go on to write plus 2x square plus 3x minus 5. We shall now write 7x plus 4x square plus root 3 multiplied by x cube minus 14 in descending standard form. We begin with the highest power of x, which is 3. Hence we write root 3 multiplied by x cube first, followed by plus 4x square plus 7x minus 14.